Okay, class DD 114-03. We're going to attempt to make a video. I'm going to put this on Facebook, and first I got the WebEx. Y'all are invited or supposed to be attending the WebEx thing tomorrow at 1 o'clock on Monday, the 23rd. Monday, we're going to see if that works. But I'm going to try to put this video, I'm going to go over this section view PowerPoint with you and see how it goes. I've got a makeshift studio here. I got props on my phone propped up, so I'm going to see if I can't get it downloaded and put on the Facebook for you. So between WebEx and Facebook, we might be able to get these online quizzes taken care of for you. And then right now the plan is to until the 6th of April, I guess it'll be the 5th April, it's going to be all online quizzes, looking at these PowerPoints and each chapter, and read each chapter. After that, if we're back in school, we're going to try to do everything on hand, by hand, all our drawings, and on the computer when we get back at the school physically. And then we're going to, hopefully that'll take us to the end of the year. I have adjusted the assignments, or I'm going to adjust. I know on chapter 8 I've X'd out one of the assignments, so we're just doing 8.5. I think I opened it, the 8.5 drawing assignment 4, because one of you have already tried to make an attempt. I haven't looked at it yet, but I will in the next day or two, and see how you did trying to use those directions. I made a PowerPoint step by step. I don't know how good it was for that person to do their drawing, but we'll see how it works out. So just be patient with me. Hopefully my wife won't walk into the office and say something to me. Nothing will fall, and I won't say anything that's inappropriate, and I'll try. So we'll start. So chapter 8, section views. And these are our objectives right here. I hope you have this PowerPoint. You have this PowerPoint in your course contents. So if you, while I was talking, had gone online and opened up your eLearn, and you could have opened up this PowerPoint and follow along with me. If you haven't done that, you can do it now while I'm going over these objectives. First objective is to understand sections and cutting planes, lines, apply correct section lining practices, recognize and draw section lines for 10 different materials, draw a section view given a 2-view drawing, demonstrate correct hidden line practices for section views, identify 7 types of sections, apply section techniques to create clear, interpretable drawings, demonstrate the proper techniques for sectioning webs, ribs, and spokes. Number 9, use hatching when using conventional breaks to show elongated objects. And 10, interpret drawings that include section views. Now, we may not draw all this stuff, but between the reading, your chapter reading, and watching this PowerPoint, and there's a YouTube video, I'm going to try to send a link to that by tomorrow, and another one of these PowerPoints from a college or university that may help explain this better. So we'll continue on. Understanding sections. Section views are used for 3 main purposes. One is to document, design, and manufacture single parts that are manufactured as one piece, to document how multiple parts are to be assembled or built, and to aid in visualizing internal workings of a design. So what they've got here is they've got a melon here, and they basically cut it in half. By cutting it in half, it's called a full section. So that little bit where the seeds are, that little hollowed out place, that would be an opening. And then around it, where the meat of the melon is, that would be your material. Okay. So, but this primary purpose is to be able to show the reader what something looks like on the inside without using hidden lines. Okay, it's a little bit more visually effective that way. Make sure my camera's doing okay. I got 50 minutes. I don't know how long this will last. I'm doing it with my phone. Cutting plain lines. That's that big, thick line. Appears as a thick dash line called the cutting plane line. The arrows at the end of the cutting plane indicate the direction of sight for the section view. So here you have a front view and a side view, and you notice the arrows are pointing away from the section drawing. Okay. And if you look on the very left side, you got that plane, the cutting plane line. That's where that line is representing cutting through that piece there. So over on the right in the section view, all the diagonal lines or section lines, those are the steel or the meat of the part. Okay, the part that doesn't have section lines, those are holes. You wouldn't have anything in there. Visible edges on a cutting plane line. Newly visible edges cut by cutting plane lines are cross-hatched with a section lining. Okay. So if you're looking at isometric there, that section drawing, you got newly cut edges now visible. Those, you notice, doesn't have section lines. Only the material that's been cut has section lines. Hold for a second. This is not very professional. I had to stop and get me a bottle of water. So my mouth is getting dry because I talk too much. So, placement of section views. Section views can replace standard orthographic views. Now, one of the ways I think would be helpful to you is draw it like a standard orthographic view. In this case, the front view and the side view. You draw that front view on the left as it would appear in an orthographic view. But then, because it's easily changed, you would have a bunch of hidden lines, and all you have to do is change those hidden lines to section. I mean, there's some variations to this, but you change those hidden lines to object or visible lines, and then add your hatching or your section lines. One of the things you got to remember in drafting, these are called section lines. In AutoCAD, it's called hatching. So remember that. Labeling cutting plane lines. So you have two cutting plane lines here. You have one cutting horizontally, AA, and one cutting vertically, BB. So this was what it would look like. AA would be one directly below the top view, and the side view over there is BB. It's the arrow showing the direction away from the section drawings. Here are some rules for lines and section views. Show edges and contours that are now visible behind the cutting plane. Okay. Omit hidden lines in section views. A section area is always completely bounded by a visible line, never a hidden line. A section line is a visible line can never cross a section area in a view of a single part. So down below here, where it says good, that's a good drawing of that section. So you have your top view and your front view there, and you're cutting the bottom half of the front top view out and drawing the section down below. If you look on the right, those are all the poor ways or wrong ways of doing section lines. And that first one at the top, you show visible lines. Okay, show the visible lines behind the cutting plane when possible. Omit hidden lines. You do not want hidden lines in a section drawing. Hatch is never bounded by a hidden line. So here they kind of mixing their terms up. Remember, hatch and section lines are the same thing. So never put those hidden lines in there in the middle. That's the third one down. The fourth one down, make sure your hatching always goes in the same direction. And the last one down at the bottom is on a single part, the hatch is never crossed by a visible line. So you see those two lines, one on each side of the hole there, they're not supposed to be there. Cutting plane style. It's made up of equal dashes, each about 6 millimeters or a 1/4 inch long in arrowheads, ending in arrowheads. This form works especially well for drawings. The alternative style uses alternating long dashes and pairs of short dashes and ends with arrowheads. This style has been in general use for a long time, so you may still see it on drawings. Both lines are drawn the same thickness as visible lines. The arrowheads at the ends of the cutting plane lines indicate the direction in which the cutaway object is viewed. Okay. Now below there you got alternative methods for showing a cutting plane A and B. Okay. And then right in the middle there they have two lines. One is, both are cutting plane lines, but one would be more of a hidden line. Okay, only thicker and bigger. And the one below is the phantom line. And the phantom line will be the one we use in our drawings. Okay. We'll go in more on that on the drawing video or drawing PowerPoint. But that's what we use, is the phantom line, which is the bottom line example. Okay, some more do's and don'ts. One on the left is good. Okay, look at the isometric above, and then look at your drawing, your orthographic drawing, which has got a front view and a side view. And in the middle there, it's wrong because, well, you've got your arrows turned, and the drawings, isometric drawing, should be on the left instead of the right. And then on the right, on number C or letter C, you've got your arrowheads pointing in the wrong direction. Okay, this slide basically pertains to mostly your old board or manual drafting days. AutoCAD pretty much takes care of most of this stuff right here, these issues. First one is uniformly spaced by an interval of about 2.5 millimeters, not too close together. Uniformly thin, not varying in thicknesses, distinctly thinner than visible lines, and neither running beyond or stopping short of the visible outlines. So if you look at the right there on top, you see the correct way of drawing section lines or hatching on a section drawing. Down below, all the no's, that's just different ways, especially like I said, back in the olden days, when you were drawing, these would be things that would happen when you're drawing with a pencil. Spacing gets irregular, drawing lines too close. Now, even in AutoCAD, you can have them spaced too close together, so you got to watch your spacing. But pretty much, I think the default takes care of that too. In the middle there, varying line widths. That means you got some that are light and some are dark. Again, AutoCAD should take care of that. Back in the olden days when you had pencils and lead and stuff, that would be something that would happen. The fourth one over from the left is lines too thick. Again, though, AutoCAD should take care of that, but you need to be conscious of that because you may have to adjust the line thicknesses for the section or hatching, okay, because they need to be lighter than the visible line around the edge. And the last one over there is lines running short or overrunning. Again, AutoCAD should take care of that, but just be aware of it if your hatching or section lines are not shown right. You need to fix it somehow. So, all right, we'll move on. Section lining technique continued. All right. When you got some weird angles in your drawing, things are going to happen. Most of the time, your section lines or hatching is going to be at a 45. If you use this, it's going to be at a 45-degree angle. But because of this weird angle in this part right here, looks like they've adjusted that section lines to a 30-degree angle instead of a 45. In the middle there, they don't want your section lines to be parallel to the outline. And the last one over there, lines should not be perpendicular. They don't want them necessarily perpendicular either to the outline. Down below, they got best when you're dimensioning. When you're putting extension lines and dimensions, you'll learn more about that, and I think it's chapter 11 when we do dimensions. Now you put your dimensions down below outside the sections. In the middle there, it's okay. There's a way of doing that, but it's not, try to avoid that if possible. And then on the right hand side, where your section or hatching is crossing the dimension, that's a no-no. Don't do that. Now, when you go into AutoCAD, well, even in old manual drawing days, board drawing days, you could do this, but it takes a lot of time. In AutoCAD, all you got to do is pick one and click on it, and it'll make your sections. So these are different kind of symbols for different kind of materials. The one up in the upper left there, the cast or malleable iron and general use for all materials, that's just the default. You can use that for anything. But you also can be specific for cast or malleable iron. Then you have the number 6 there. It says rubber, plastic, and electrical insulation. Number 11 is electric wingdings and electromagnetics and resistance. Then you have sand, and you have steel and cork, felt, concrete. If you're going into architecture, you'll need to know about how to draw the concrete in there, okay? Water and other liquids, bronze, brass, number 3 there. Number 8 is sound insulation. Number 13 is marble, slate, glass. Number 18 is wood. And then you have white metal, thermal insulation, earth. Okay, there's even section symbols for earth. Magnesium, titanium, and then last is rock. You can put rock in there. These are not all of the symbols either. This is just the basic ones, okay? Okay. Section lining in CAD. Okay, now we're going to talk a little bit about CAD. CAD programs usually include libraries that allow you to select from a variety of section lining patterns, making it easy to use different patterns, angles, and scales for the spacing of the pattern. Okay, on the left there, this is a wall section. It's the ductwork. It's a vent. It's dampers. You can open and close. It's got a little motor there, an access door, I guess, for you to work on the damper motor if you have to. But down below in the green, where it's really dark green, it's saying the section lines are too dense. So you're going to have to adjust that. And then you go above it, and it says the section lines are too sparse. That means they're too far apart. They need to be close together. So somewhere in a happy medium there between the bottom and the top would be suffice. Half sections. You can do half sections. Remember at the beginning we cut this melon in half, and we called it a full section. Well, we cut a quarter out of this melon, and we called it a half section. So symmetrical objects can be shown effectively using a special type of section view called half section. A half section exposes the interior of half of the object and the exterior of the other half. This is done by removing 1/4 of the object. Okay, so if you look down below there on the left, the cutting plane, only 1/4 of that drawing has been cut away. Okay, so when you draw it on the right side, the half section, half of it looks like a normal orthographic drawing. Okay, and the right side is your section drawing. So you get both. You get example of both worlds. You got a section on one side, and you got the orthographic view on the left side. And notice how the cutting plane line goes to. It doesn't go all the way through. It actually starts at the middle of that circle, the bottom quadrant of that circle at the top, and goes up to the center and then to the right, and then the arrowheads on the left, or on the right, I'm sorry. Here's a broken out section. It often happens that only a partial section of a view is needed to expose the interior shape. Such a section, limited by a break line, is called a broken out section. So you have this part on the left there, and you got a little piece of it cut out in the front, and it's to show that little hole there. It's probably some sort of grease fitting, to oil it or grease it, and they want to show that hole in there, and they want to show some detail. So they cut that portion out, just that little corner up there, and they put a broken line to indicate where it's broken out. So I don't see a section line a cutting plane line on it, so I guess it gets one. So, but that's what a broken out section looks like. Revolved sections. Okay. That means what you do is it kind of like it has spokes, and you actually rotate the spoke so you can see what that spoke looks like. So that's what they're doing here. The shape, excuse me, the shape of the cross section of a bar, or arm, or spoke, or other elongated objects can be shown in a longitudinal view by using a revolved section. To create a revolved section, first imagine a cutting plane perpendicular to the center or axis of the object. Next, revolve the plane 90 degrees about a center line at the right angle to the axis. So all they're doing is rotating that section. You're putting your section line in there, and you're rotating that shape inside there. So it would show that, I don't know, looks like an eye. So on the right hand side. Okay. Remove sections. Okay. A removed section is one that is not in direct projection from the view, containing the cutting plane line. That is, it is not positioned in agreement with the standard arrangements of views. So here they've got a little drawing on top there, and it's got a little section AA cutting plane line going through it. And then down below, they've got that same drawing in section, and instead of being full size, it's 4 times the size. They did that to scale it up so they can put the dimensions in there so you can see them properly. Okay. Offset sections. In sectioning complex object, it is often desirable to show features that do not lie in a straight line. By offsetting or bending the cutting plane, these are called offset sections. I'm sorry. Okay. Basically, if you look at the path of the cutting plane line there in the top view on the right, it's going through that little small hole on the left and turns up and goes through that slot, and when it gets through the slot, it turns up again, and it turns right and goes through that hole, and when it gets through that hole, it comes back down and it goes through that little hole on the right and then back through, and then you got your arrow. So in the left top view, you have that path, shows the cutting plane path, and down below it shows the material, what's going to be sectioned and what's not going to be sectioned. Then on the right hand side, you have the top view and the front view. Okay, so your front view right there should look like something like the left isometric drawing B. Okay. The only thing I see on there that they tell you earlier not to do, and that's put hidden lines in there. And so I don't know why they put those hidden lines in there. I guess there's a reason for it. Ribs and sections. Say ribs. To avoid giving a false impression of thickness and solidity, ribs, webs, gear teeth, and other similar flat features are not hatched with section lining, even though the cutting plane line slices through them. Thin features are not hatched, even though the cutting plane passes lengthwise through them. So on the left there, A is showing the front view and the top view. Okay, so BB is the section drawing for the top. And on the right hand side, there's on B, which is your side view. That's good because that's the way it should look like. And then C is the pour way. You're not supposed to section that web, that little piece of thin metal between that circular area on the front view, that circular hole, and the bottom there, that plate that goes across. That part that's in between there is called a web, and you're not supposed to section that. Okay? Hope that makes sense. A line section. Now, this drawing is basically would be a very confusing drawing if you drew it in its proper in location. So what happens here is when parts with angled elements are sectioned, the cutting plane may be bent to pass through these features. The plane and features are then imagined to be revolved into the original plane. The angle of revolution should always be less than 90 degrees for an alignment section. So if you look at the front view on the left, what they're pretending they're doing is revolving that bottom piece down vertically, and then they're projecting their lines over and drawing that bottom piece that way. There would be a lot of lines, and it would be mass confusion of lines if you do it the right way. In this case, to clear up and make it more understandable, they pretend they rotate that piece down and project lines over and draw it in like they've got it in the right view there. Make sense? Partial views. Space is limited on paper to save time. Partial views may be used with sectioning. Okay. A is a full section. B is a partial section. And C is, it's more or less a revolved. They have revolved and partial sections and different. Another method of drawing a partial view is to break out much of the circular view, retaining only those features that are needed for minimum representation. So you can do this if you want to save time and you're limited on your paper size. Okay? Intersections. When you have intersections, like in the A there, you have this rectangular hole going in the side